Okay, welcome to today's webinar. This is the fourth day of our 5-day Getting Started with Cloud and AI on AWS. This is a beginner-friendly introduction to cloud computing, AWS, and some introductory elements of AI. Okay, and the whole idea behind this 5-day program is to help you visualize just how cloud computing is, if you're interested in a career in cloud computing and maybe even specifically AI, then how cloud computing forms the foundation of AI technologies. So we've been running since the beginning of this week. On Monday, if you attended, we had an introduction to cloud computing and identity and access management. Tuesday, we started to look at storage services and content delivery networks. Yesterday, we were looking at EC2 instances, Lambda, and ACS. And today, we're going to look at some AI services. We're going to do a quick introduction to AI technologies and some conceptual understanding behind what AI is, covering things like machine learning and generative AI at a very high level, covering some basic concepts that you should be aware of. And then we'll start taking a look at some of the tools and services that AWS offers you to help you build AI-related applications. Tomorrow is going to be an amazing day because tomorrow we're going to actually build a subsection of an application where you can see all of the different technologies we've used this week and learned about this week to build a particular working model of a particular application stack. Okay, we're not going to do the end-to-end application, obviously, but we are going to do a very important subsection of that application. If you've joined us right at the beginning of this week, I have been talking about a web application that helps you convert your resume into a website. And we showcased a product called Lovable, which is an online AI tool. And there are several AI tools. So I just picked Lovable out of the hat, to be honest. It was just random. But essentially, that site or that web application allows you to create websites based on prompts. Okay, so you prompt it with something, you might give it your resume in the form of a PDF document or a Word document, and it can generate a website for you, which you can then send the link off to recruiters, hiring managers, etc. I've taken that as the basis of this course this week because what we're going to be doing tomorrow is we're actually going to do something similar, only with a little bit more emphasis on how we can make the output deterministic. So let's get on with today's session. As usual, this is going to run for a maximum of 2 hours. We might finish a little bit early. If you have any questions, use the Zoom chat, or if you're joining us on YouTube Live, then obviously you can have a chat with us on YouTube Live. Some of the questions I will be able to answer whilst in the session, others I might leave till the end, but otherwise I'm going to try and focus on completing today's session. We've got a lot to cover. So today's session, again, like I mentioned earlier, is going to be a quick introduction to AWS AI and AI tools and services on the AWS platform. So far, we've covered days 1, 2, and 3. This is day 4. And so we're going to be looking at some 4 key different AI technologies on AWS. We're going to take a quick look at Bedrock, Recognition, Poly, and Textract. And incidentally, a couple of those technologies are what we're going to be using tomorrow for the hands-on demonstration as well. Okay, before we go any further, I've got a hand raised up by Rajkumar. Rajkumar, do you have any questions? You can feel free to just put it in the chat, actually. Yeah. So if you've got any questions, please put it in the chat or the Q&A. Okay, because this is a webinar, we have an enabled voice. But by all means, if you've got any questions, then please put it in the chat or in the Q&A, and I'll do my best to answer. Okay. All right, so let's get started with today's session then. So we're going to do an introduction to AI and ML services. And just give me a quick second here. Okay. Here we go. Okay, yeah, so just to reiterate, if you've got any questions, put it in the chat or the Q&A, because those are the 2 mediums that are available on this webinar service, okay? Okay, right, so we'll get started with an introduction to artificial intelligence. Now, you probably already know so much already about what artificial intelligence is, but we're going to take a step back and look at an overall definition and how the different elements of artificial intelligence actually work. So artificial intelligence is a broad description of basically creating machines that can perform tasks that normally would require human intelligence. Okay, this is the overarching definition of artificial intelligence. So things like understanding speech, recognizing images, making decisions, and solving problems. And you can think of AI or artificial intelligence as this big umbrella underneath which we have several specialized fields of AI. Okay, so we've got machine learning, which is a branch of AI where systems basically learn from data instead of explicitly being programmed to certain rules. So it's basically a method that we teach machines to learn from data. So the idea is we feed data into a machine learning algorithm, we train it up with all of that data set, and then it's able to make predictions based on any new data that's supplied to it that's related to the data that it was trained on. Obviously, if you supply data to a machine learning model that's unrelated, it wouldn't be able to make predictions. Okay, so initially what you have to do is you have to supply it with data and it gets trained on that data and then it's able to make predictions. So take the example of Netflix, Instagram, YouTube, whatever it might be. It's going to analyze what you've watched, compare your behavior with similar users, and then it'll be able to do things like predict what you potentially might like to watch next. Machine learning is great because they help you build applications that can do things like spam filtering, navigational apps that will choose the fastest route to your destination, online shopping recommendations, etc. Okay, and machine learning, therefore, is a methodology to help you achieve applications that can perform all of these tasks. Now, next we have deep learning. Okay, so in that hierarchical structure, under that artificial intelligence umbrella, got machine learning, and then you got deep learning. Deep learning is more advanced form of machine learning that uses artificial neural networks that's been inspired by the way how the human brain works. Okay, you have something called an input layer. This is where you obviously feed massive amounts of data into the deep learning system, and you have multiple hidden layers that then learn from that data. Okay, so you have hidden layers where the real learning happens. So earlier layers may be able to, decipher and detect things like simple elements of what you're inputting. So if you're inputting some images or some recordings or some audio, so it might be able to detect things like edges, colors, sounds. Layers that are deeper will start, detecting things like shapes, recognizing patterns, and even deeper layers might then be able to identify faces, spoken words, and language meaning. And then you obviously get an output, right? So finally, the output produces your prediction or your decision that you have. So for example, if you have things like, your phone where you're using biometrics, so you're using facial recognition, you're using voice assistants like Alexa or Siri to basically detect your voice and to listen to you and figure out what it is that you're trying to say. Self-driving cars that recognize pedestrians and road signs and traffic signs. So things like, the Tesla, for instance, they use things like deep learning technologies in order to be able to perform all of those activities. And then you've got below that generative AI. Now, generative AI is a step further, and it's a subset of deep learning. Okay, and instead of just analyzing and predicting, making predictions, it's actually able to create new content. Okay, so it can generate text, images, video, code, and you are able to produce all of that by simply providing with certain prompts. So things like, using ChatGPT to write articles, Midjourney to create images, and so on and so forth, or other AI tools to generate code. So you probably played around with some AI tools already that can allow you to generate code or generate websites. that's generating new content for you, which is why when, a couple of days ago when we were looking at Lovable, you saw that when I uploaded the PDF document, which contained the resume, it was able to generate a website of the content of the resume, but it was almost like it was creating some new content because the website looked different. Okay, so it's based on probability and what it needs to look like and how it should be fancy and everything, but it creates brand new content for you. So that's where generative AI comes into play. Okay, and so when it comes to real world use cases, then you've got AI, which is great for things like, and the use cases are smart assistants, robotics, autonomous vehicles. You've got machine learning that's used for things like fraud detection, recommendation systems like your Netflix, spam filters. You've got deep learning, which is can allow you to build applications like medical imaging, voice recognition, self-driving systems. And you've got generative AI, which allows you to create brand new content, AI art, text generation, code assistance, marketing content, that kind of stuff. Okay, so that is an overarching explanation about what the AI umbrella is. So you've got AI, ML, DL, and obviously Gen AI. And then if we take a look at machine learning next, it's a good idea to just understand the fundamentals of how machine learning works, because then we can see how deep learning works further along the way. So machine learning, as I explained earlier, is just basically this field of artificial intelligence. Computers learn patterns from data and make predictions or decisions without being explicitly programmed to do so. Okay, so normal software that you create has a step-by-step process that you explicitly tell the software what to do. Machine learning goes through and analyzes and looks at lots of data, analyzes the pattern in that data, and then is able to make predictions. So it automates decision making. It learns from past data using an algorithm. It improves over time the more data you feed it and it's collected. And it can be used for things like predicting exam results, recommending learning videos, or identifying at-risk students for a university, for example. Okay, so here the way how it works is we supply it with known data. And specifically, we identify features of that data. And when I say features, I mean things like, study hours. So if we're looking at an example of predicting university students that can pass the exam, okay, or pass their degree or get their degree and get a, first class honors or a 2-1 or whatever it might be, we can input data with various features. These features could be things like study hours, attendance, assignments completed, etc. And so you can think of features as basically attributes of that data. Okay, we feed that into the algorithm, and that algorithm is going to get trained on patterns and recognize various similarities and also recognize, how those patterns are being created. So you go through a training process and you get some sort of output. You can also perform something called feature engineering, which is where you want to make sure that the algorithm is trained more accurately. It's like it's got the ability to really understand the data you're supplying it. So in a lot of machine learning use cases, the first thing you have to do is make sure that the data that you're supplying the model or the algorithm has been cleaned, is readable, it can understand that data. So you may need to perform some feature engineering tasks like converting formats. For instance, it's better at understanding decimal numbers rather than percentages. You want to remove missing words. You want to remove any kind of words that is wrong data, for instance. You want to create helpful features, like you might create some connections between the individual features. So engagement score is equal to study hours plus attendance. The higher the engagement score, the better it is, kind of thing. Okay. And as you go through this process of repeatedly training your model, what's happening in the background is it's beginning to get better and better until you get to a stage where you're finally getting the kind of output that you would expect from the data that's being supplied to it. Okay, so you need to monitor it and obviously see that it's learning correctly, it's got the right data set, and it's able to, therefore then start understanding or being able to analyze and see the patterns of your data. At that point, you essentially have a model that you can then use. Then you can supply it with new data. So next year's intake at the university, you're monitoring the students, you're supplying data, for instance, things like, study hours, attendance, etc. You're providing all of that new data set to the model, and the model is then able to infer and make accurate predictions as to what what's going to happen, which students are going to do well, which students are at risk, that kind of thing. So this is where machine learning really shines. And so if we take a look at predicting, using that example to predict the exam performance, so if the goal is to predict whether a student will pass or fails based on attendance and study habits, then the high-level process will include things like collecting data, study hours, attendance, pass grades, processing that data, cleaning it and preparing it, okay, and training the model to learn those patterns, making predictions for new students. And your data set can come from any sources. So on AWS, we can extract that data from databases, from CSV files, from any kind of data that you have, which you can then upload to something like Amazon S3, and then use that as the storage area for all of the raw data. Ultimately, you can then have the ability to make predictions. So if Anita is studying for 10 hours and has 95 attendance, the model is going to say, right, she's likely to pass the exam. Whereas Ben, who's only done 3 hours of study and his attendance is a bit poor, he potentially could fail the exam or fail the course, right? So that's how we basically use ML. And ML is this tool for learning patterns. But you need to understand that ML isn't just all AI. Okay, so there's all of those other layers within artificial intelligence itself. Okay, so next we're going to move on to generative AI. Are there any quick questions? Is everyone okay so far? Yeah, if you're okay, just let's have a thumbs up in the chat, and that'll be great. Okay, awesome, good, thank you. Okay, so let's move on and let's talk about generative AI, the one that's really exciting. Okay, so generative AI works differently. Generative AI uses deep learning as its basis for being able to create all this wonderful content that you're creating, whether you are summarizing a document, whether you're telling ChatGPT to write your emails for you, okay, whatever it might be. Generative AI is made possible because of deep learning capabilities. So let's understand some of the conceptual theory behind how it all works first. So traditional ML, traditional machine learning, right, analyzes input, returns a classification or a prediction, and the answer is always formed from a fixed set of possible outputs. Okay, it can only choose. So if you take Netflix, for instance, Netflix is only going to be able to predict those videos that it has in its library based on your past usage and what it is you've been watching, right? So examples include things like, is the email spam? Yes or no? Is the image of a cat or a dog? Will this customer churn? Okay, so that's predicting based on how the customer is interacting with you and your company and your e-commerce website. Are they likely to churn? What product to recommend? Okay, so product A, product B, product C, based on what you have in your product catalog. Generative AI, entirely new content is created that didn't exist before. It could be similar, it could be looking very similar to what's already out there, but it's usually new content that is generated, and it's open-ended and therefore unique to the input. So based on the input, the prompt that you give it is going to generate some new content for you. So summarizing a 50-page report, if you summarize a 50-page report now and take that 50-page report and summarize it 5 minutes later, you're going to get a good summary, but the output is going to vary slightly. Okay, so the context or the conceptual understanding of what that document is all about is going to be the same, but it just might relate to you in a slightly different way. Okay, so you get unique summaries every time. Write code to sort a list. Okay, so it can create new code for you. Translate this document, it can perform translations, and answer this question in plain English, so it can give you an explanation as well. Okay, so these are the type of activities you can perform with generative AI. So traditional ML is close-ended, picks from known options. Generative AI, open-ended, creates something new every time. Okay, and so to try and understand the inner workings of how generative AI works, the first thing that we need to take a look at is this thing called the capabilities or the various technologies that are sitting behind generative AI. So you've got generative AI versus traditional AI. So generative AI, as I mentioned, creates new original content. But what you have is these things called foundation models. So these are large, complex neural networks with billions of parameters learned during a pre-training phase, and they've been supplied with vast amounts of data, pretty much the entire internet, okay, books, videos, images, etc. And they're trained on all of that data set. So they pick up statistical patterns across different modalities. And we're talking about things like language, images, videos, text, whatever it might be. And the bigger the more the parameters, the more the capability of it. Now, if you're wondering what a parameter is, basically it is these tiny adjustable values that help AI decide how strongly to connect ideas together. So for example, the model is going to learn that a cat is related to an animal, that Paris usually means France, that AWS is related to cloud computing. And during training, the model will adjust all of these billions of parameters so that it gets a better at predicting the next word or making or understanding meanings behind it. So here's another example. If you tell, a student, the sky is blue, or the ocean is blue, or that car is blue, the brain starts to understand that this word blue, okay, is really important, but also that it means different things in different contexts, okay, and has different contextual meanings. So parameters are basically the AI version of those learned connections. And so the more parameters that a model is able to offer you, the better it is at predicting and and generating content at the end of the day. Okay, now there's also what actually makes today's generative AI and the tools and services that you're using to possible is this thing called the transformer architecture. Okay, it's a core element of modern AI, and basically it was introduced in a white paper called "Attention is All You Need" back in 2017, and it's what powers today's modern LLMs like ChatGPT and Claude and all of that. Okay, so it's pre-trained on massive internet data, broad knowledge, and essentially the transformer architecture is the AI system that helps model understand relationships between words in a sentence. And even when the words are far apart from each other, it's still able to decipher and work out what that sentence actually means based on all of the massive amounts of examples and data that it's been trained on. A transformer basically helps AI pay attention to the most important words and context when reading or generating text. And basically, that's where it really shines. So I'll give you an example. Let's say we've got a sentence. Rajesh put the book on the table because it was heavy. The transformer is what's responsible for making the AI understand that the word "it" relates to the book and not the table. Okay, because it's seen this so much, it's being able to understand that this is how sentences are structured. It's able to now decipher that "it" here refers to the book rather than the table. Okay, so the book is heavy, the table, it wasn't heavy in that sentence. And this is based on what is called attention. I'll come on to attention in a minute. But essentially, AI does not read one word at a time, like all the models. What it does is it looks at all of the words together and then makes a decision as to which words are important, how the words relate to each other, and what sentences really mean. Okay. So if we take a look at how a model generates output, you obviously supply it first with, as I said, your training data. You go through this pre-trained models where, pre-trained produces foundation models with billions of parameters, and then you make a decision exactly how many parameters you're going to have. And then at inference time, which is also known as runtime, okay, input is passed at this runtime. And that's where it analyzes the input, which could be basically an instruction and some content. And then the model will output a completion, which is essentially guessing what the next word or token should be. And I'll come on to what tokens are in a minute, but it uses probability and prediction ultimately to generate text, to generate any kind of content, whether it's images, video, or whatever, in order to complete the task that has been given. Okay. So let's talk more on transformers because it's important that you actually understand this a little bit more. So the transformer architecture is basically the core AI design that powers your ChatGPT, Claude, Gemini, etc. Imagine you're reading a sentence. The cat sat on the And obviously, you then need to predict what that next word is. So hopefully you know what that next word is, right? The cat sat on the, mat, right? Your brain is going to look at earlier words in that sentence. It's going to look at cat, sat, and then it's going to predict the next word, mat. Why is it going to do that? Why are you saying that? Why are you predicting the cat sat on the mat? Why not the cat sat on the table or the cat sat on the car? What makes that happen? It's because you have seen that so many times. It's because you have witnessed that sentence or you've read that sentence so many times that it's just obvious that it's potentially probably going to be mat at that last word. Okay, so Transformer will read all of the words in the sentence at once, not one by one, like all the AI models, and figures out which words are important to each other, understands context and relationship, and then predicts the next token, the word, part of the word in that. Okay, so it is this neural network architecture that ultimately helps our Gen AI understand relationships between those words, tokens, using attention and enabling intelligent text generation. So the next question is, how does it actually read these words? How does it actually understand these sentences? Obviously, it's a computer, okay? So computer technologies work with numbers, and more specifically, at the end of the day, in binary. But models can't actually read words. They only understand numbers. So here's how a text gets translated into something that our models can work with. So we have that text, the cat sat, okay? Something like the cat sat on the mat or whatever it might be. That actually gets converted into something called tokens. Basically, tokens is where we split the sentence or the text or the paragraph or the book into smaller pieces called tokens. Now, a token can be a word. It can be part of a word. It can be the ending of a word, like ing at the end of beginning. It can be just a single character. Different models will use these tokenizers, which perform the actual breaking up of the text into these smaller tokens. And different models will use different tokenizers, which is why when you're comparing models, you might notice that they produce different token counts when you are generating content. So these tokens or these individual words or part of a word or single characters then get converted into what are called token IDs. Now, token IDs are basically where the token, so cat, for instance, gets looked up in the model's vocabulary. This is a giant dictionary mapping tokens to specific numbers. Okay, so the word "the" usually has a particular token ID, right? The word cat will have a specific token ID. And this output is, and so you have this conversion from the words into these token IDs, also known as input IDs, that ultimately is something that the model is going to use. Now, we take this one step further. Each token ID is then converted into a numerical vector, which is essentially an ordered list of numbers. Okay, and that's what the model is working with. It's these vectors that the model is working with. So the tokenizer is this component that will split the text into tokens, and it will look up each token ID in the model's vocabulary. And then the vector is this ordered list of numbers that pins each token to a specific location in a high dimension space. Okay, so I want you to think of this in more simplistic terms. If you think about a vector, it basically indicates a location in space. If you look at an example, a simple example of a spreadsheet, okay, if you take a simple spreadsheet, the location of a particular cell is going to be determined by the column heading and the row number. Okay, so A7 versus F30. Okay, so these are different locations on that two-dimensional space. And what the model does is it places these individual vectors and specifying the locations of where it places them. So we end up with a situation where we have all of these numbers, and these numbers are essentially being defined on this high dimensional space at different locations. On their own, they obviously don't mean anything, right? So a bunch of random numbers on its own isn't useful at all. So the next step is to actually make those numbers mean something. And that's where we use something called embeddings. Okay, so we take this one step further, and essentially embeddings is this high dimension of vectors that will capture the semantic meaning of a token. Okay, and essentially the way how it works is the position is equal to the meaning. So tokens that mean similar sit closer together in that vector space. Okay, so we and we also have what are called relationships that are preserved between them. So if we take a look at an example, and this is probably a simplistic way of explaining it, but essentially if you look at a two-dimensional space, similar tokens will be clustered together because they have some sort of related meaning with each other. So we've got a cluster of king, queen, and prince that are being placed closer together because semantically they relate to royalty. Okay, so on this vector space, they're placed in this area, for example, and this is just for illustrative purposes. Likewise, cat, dog, and rabbit might be placed in a different area, in a different location of that vector space, because they are related to domestic pets, okay, animals, for instance, right? So this ability to place different tokens in different locations allows us to basically, relate them a little bit better into what they're meaning. And we take this one step further because what happens with these vector databases and with vector solutions is that it goes one step further because modern transformer models are able to also adjust those positions based on context. So what do I mean by that? So for example, you've got another two clusters. You've got here warm coffee, hot tea, boiling water. So it relates to temperature. So it's being placed in a specific location in that vector space. And then you've also got warm welcome and kind gesture, which is related to emotion or personality. And that's being placed in another location. What you will notice is modern transformers are able to adjust and be even smarter because they're able to understand that warm here, okay, warm coffee relates more to temperature, and therefore let's put it next to the temperature cluster, and warm welcome relates more to personality or emotion, let's place it in that other cluster. So this allows us to get to a situation where now your transformers is, getting even smarter and able to understand concepts around the actual word that's in question. So the word is warm, but because warm coffee is really different from warm welcome, it actually is able to place warm coffee closer to something like hot tea and boiling water. And so that's where it's beginning to learn and really actually develop its capabilities in being able to provide you with with meaningful predictions and meaningful outputs. Okay, so this is great. So far, this is great, right? You've got each token has a meaningful vector, but the meanings on their own still isn't enough, right? Because I could say warm coffee and warm welcome and king and cat and dog or whatever, and that's great. We know what they relate to now, and this is fantastic, but it doesn't end there. Because now we also need to understand how these individual words actually mean in a specific sentence, okay? So this is where we have something called self-attention, okay? And self-attention, so if you look at it, so when we look at the meaningful embeddings of each token, each meaning in isolation will not be enough. The model needs to figure out the specific sentence and how each word in that sentence relate to each other. So here we use something called self-attention. And self-attention, if we take the same example as the cat sat on the mat, okay, for each token, the model is going to ask, what other tokens should I pay attention to? So in a sentence, the cat sat on the mat. Okay, fine. How do those individual tokens now relate to each other? And if we take something like, for instance, if we highlight cat as the focus token, compared to that focus token, how does each other token weigh up against it? Okay, so we have this ability then to identify which of the other tokens pays more attention or is more related to what it is that we're actually talking about. So if in the case of the cat example, then we're more interested in sat, where the cat is, or sat, what the cat is doing, and mat, where the cat is. So it's sitting on the mat. Okay. So you will see that on the contrary, something like the and on have less weight, okay, when comparing to something like sat and mat. And this is something that's being done for every token in that sentence and all in parallel. So another example is the cat drank the milk because it was thirsty, right? The it refers to the cat rather than the milk because through past training, the models understood that cat can become thirsty, right? But milk can't become thirsty, if you see what I mean. Okay, so this is something that you need to understand. And so when it comes to the way how things like, foundation models like ChatGPT or LLMs like ChatGPT work, you've got transformer architecture, you've got self-attention, and this ability to then understand the meanings between those individual words in that sentence to build that context. So you've got key transformer concept. You've got self-attention. So for every token, what it's going to do is it's going to compute something called query, key, and value vectors. Now, we won't get into the math of it, but basically it weighs which other tokens matter most in that sentence. Long-range context is also able to capture relationships across long sentences. Even if the words are far apart from each other in the sentence, in the case of the cat drank the milk because it was thirsty, it relates to the cat rather than the milk, right? It's able to figure that out, something that older RNN architectures were struggling with. You've got position encoding. So this tags each token with its position. So the model now understands the word order as well. Okay, so dog bites man doesn't mean the same thing as man bites dog. And then you've got something called encode and decode, and stack layers build up complex representations. And this is what was introduced in that white paper, Attention is All You Need. Okay, so hopefully this is now beginning to make sense that using all of these different elements, that models today that you're using, the LLMs that you're using today are far more sophisticated and able to naturally converse with you as humans because they're able to understand entire sentences. They're able to grasp or identify through statistics and through probability and through math, at the end of the day, what those individual words and tokens mean in relation to other words and tokens in that particular sentence, in that particular paragraph, in that particular book. And the same thing applies across all modalities, right? Whether it's text, language, text, images, sound, audio, and video as well. Okay, so this is all great. Let's take a look at how AI actually reads as well. Okay, so one of the things that you do is obviously you supply AI with a lot of data, right? You might be giving it a big book to summarize, for instance. How does it actually read that book or that document and is in a position to then understand that context? So models can only read a limited amount at a time, okay? And long documents end up being broken into chunks. Now, how those chunks are presented to the model is really important because if you just randomly create chunks and break up your document into smaller sentences or individual words or whatever it might be, you are potentially going to lose meaning. Okay, so there's something called a context window. So the maximum amount of text that a model can read in one go. So ChatGPT 4, 128 tokens, but a 500-page report may have billions of tokens in it. Okay, so it needs to be split up. Now, when we split up these texts, we need a mechanism in which we can maintain contextual meaning. So we do something called overlapping. Without overlap, we end up getting into a situation where the meaning can be lost. So for example, let's say that the patient was prescribed metformin, the dosage was, and then the next chunk was 500 milligrams twice a day. Side effects include nausea. Okay, so metformin is a drug for diabetes. So basically here we're supplying some medical information, okay, but the chunking of it is in such a way so that it's just cutting off the words completely, okay? So it's just going for the next word in that sentence. So the patient was prescribed metformin, the dosage was, and then there's a cut. The next chunk is 500 milligrams twice a day. Side effects include nausea. Now, in this situation, the dosage was at the end of chunk 1, 500 mg at the start of chunk 2. The model reading chunk 1 alone will never know what the dosage is, okay? So instead, what we do is we use overlapping. And that's where we share tokens to bridge the gap. Okay. And so instead, what you could do something like is say chunk A is prescribed metformin, the dosage was 500 mg. And then the next chunk would be something like the dosage was 500 mg, side effects is nausea. Okay. Here, what we're doing is we're having an overlapping of those tokens. Okay. So each chunk, when compared to the next chunk, there's some overlap between them. We're repeating tokens if necessary, and obviously this means that it's consuming more resources, but by doing so, we're actually ensuring that the dosage was 500 mg, that context has been preserved, okay? And the model reading either chunk now fully understands the meaning. So context window limits how much text a model can read at once, and you need to ensure that, or these models use this overlapping mechanism to ensure that that meaning, that contextual meaning of those sentences, of that prescription, of that doctor's report is being maintained. Okay, let's talk a little bit about, and again, feel free if you've got any questions so far to drop it into the chat, but let's talk a little bit about prompting and inference and some key terms here. So a prompt is exactly, what you have been doing when you've been using ChatGPT, Claude, or whatever. You input basically an instruction, and you may also supply some content with it. Okay, so a prompt to completion cycle, you provide an instruction and you provide some content. So you might say, summarize this document for me, or convert this PDF document into a fancy website. That's the instruction, and you have some content. Okay. And then what it does is it performs an inference at runtime. So the prompt is passed to the model at what we call inference time, after the model has been pre-trained, and inference. And we can also configure this, by the way, the actual how it infers and how it analyzes that that input. I'll talk about that in a second. And then it proceeds to completion, where the model, the output is then what the model generates. Okay, and this could be, whatever you have asked it to do, summarize the document. So it'll summarize the document for you, and that's the output. So that's fantastic. Now, in terms of when you're prompting your model, you can perform what's known as in-context learning as well. So this allows you to get better outcomes and better outputs from your model. So you can perform what is known as in-context learning, where you provide examples of the type of output you want at the time of prompting it. And we've got 3 different flavors. You've got something called zero shot, which is where you don't provide any examples of the response or the output you want. You've got one shot, which is a single example to anchor the task, or few shot, where you give multiple examples, which evidently provides you with a lot of more richer context. So I'll give you an example. Let's say that we're giving a prompt to an LLM to say, given the following examples, example 1, Amazon S3 provides highly scalable object storage for files and backups. Example 2, Amazon EC2 provides virtual service for running applications. Complete the following sentence. Amazon RDS provides, and then the model is going to go through and understand those examples, that few shot multiple examples that you've provided it, and provide a response to you in a similar fashion. So it'll come up with something like Amazon RDS provides a managed database service for storing structured data, for example. Okay, so you've got this ability to perform what's known as in-context learning. Another type of prompting that you can do is known as chain of thought. This is where AI will break up the problem into smaller steps and do a step-by-step reasoning before giving you the final answer. This is particularly useful when you want the model to solve complex problems, through accurate reasoning and going through step-by-step processes. Okay. So in terms of just some terminology and some key terms that it would be good to understand here. So you got things like, you got your prompt, which is the input that you send to the model. Inference is the runtime when the prompt is passed in to the model. Completion is where the model generates output. Tokens are the number of units that the model actually processes. Context window is the maximum tokens that the model can see at once. And then prompt engineering, you got various techniques to try and craft your prompts to get better outputs. Okay, so hopefully this is giving you an opportunity to see exactly how generative AI works. And hopefully you can see through the iterations that we have had over the years today, the way how our models are functioning and how they're capable of is all thanks to all of that transformation architecture that's been improving with the self-attention and with various additional approaches of prompting, etc. I'm just going to stop here for a second and take a look at, I can see there is some Q&A. Just give me a second. Okay, so you've got foundation models which are based. So just answering Vinayak there, can you give examples? So basically, you've got foundation models that are actually able to provide you across different modalities. Large language models are mostly text-based driven. Okay, so large language models generate text-based driven. Nova Pro, would their foundation models be the same? Not necessarily, because each organization like Amazon, for instance, are building their own models at the end of the day. So there would be different, different approaches in the way how they've built it out, the type of data that they've provided it, and any kind of backend functionality that it also has. Okay, is there any correct way of prompting, like short, crisp prompts versus detailed prompts? Absolutely, there's a whole thesis basically when you think about it in terms of prompt engineering and the way how you prompt your LLMs. And then this also depends on the type of LLMs and the models that you're using as well in order to get better outputs from it. Okay, that's obviously a whole different course in itself. But yeah, definitely there are different ways of prompting. To begin with, one of the ways that you can really improve and increase your responses or the kind of responses that you get from these LLMs, from these models, is by improving the way how you prompt them. So being articulate in what it is that you're expecting the LLM to provide you with, the model to provide you with, right? Using things like your in-context learning, your few short examples that you can give your prompt, for instance, that's a great way to get the kind of output that you're looking for. And giving examples to the model and how it should generate the response, whether it should be in a particular format, whether it should give you a table, whether it should, give you bullet points. All those specific things are really important when you're performing your prompting and your prompt, and all form part of your prompt engineering. There is another element to it, and we'll take a look at that when we start looking at Bedrock, and that's called a system prompt. So there's a difference between a user prompt and a system prompt. A system prompt defines a set of rules and guidelines as to how the model should respond to you. And I'll talk about that in a second as well. Okay, just seeing if there are any other questions. Bear with me. Okay, great. So let's move on and talk about Bedrock. Okay, so Amazon Bedrock is this fully managed generative AI service that basically gives you, as a cloud engineer, a cloud architect, a developer, whatever you want to call yourself, the ability to interact and access the vast array of different models out there, okay, and from different providers like Anthropic, Meta, etc. Okay, so instead of building and training, hosting large language models yourself, Bedrock will abstract that heavy lifting for you. So you focus on building applications. And to be honest, in 2026, unless you've been in the AI and ML industry for a long time, you have all of these existing models that already exist. So you're going to spend most of your time, especially if you are starting out in the industry, starting out your career in this industry, you potentially have more opportunities now to build applications that consume and use these models rather than necessarily building a model from scratch. I'm not saying that that doesn't happen as well, or that there aren't any opportunities there, but that's a whole different career roadmap, if you will, if you wanted to get into that sort of training and career development. In 2026, you're potentially looking at becoming an AI engineer or an AI architect. And that's where you're using existing AI models and tools and services to build your application solution. Okay. Okay. So Bedrock allows you to basically connect your application to Bedrock, and you can access your various models from it. It's got full API access, which means that your application can be programmatically accessing those models through Bedrock. Okay, so it makes life a lot easier for developers. It comes inbuilt with a lot of security and governance. You can implement guardrails and security features so that the model doesn't do something that's incorrect or wrong. And there's no infrastructure to manage, right? So you've got full access to the core infrastructure that AWS has provisioned. You don't have to build your own servers and stuff to start hosting the models in any way. Okay, it's got full API access for you, and you're just building your applications and you focus on your application development. So fully managed generative AI service, access to leading foundation models, build Gen AI apps with APIs and no infrastructure to take care of. And so it's your app that connects to Bedrock that then accesses those foundation models, those LLMs, and then subsequently you get your AI responses and you can generate content or whatever interaction you want to do with your end customers, whether it's a simple chatbot or it's a chatbot that's smart and intelligent because it references your company data and documentation, for example. And then there's this whole new world of AI agents, which obviously we will not touch today. But at the end of the day, you've got so much more advancements taking place in that arena as well. So you can think of Bedrock as a Netflix for your foundation models. You can go and select whichever model you want to use at the end of the day. And not all models are the same, right? So one of the things that you might have to do as a cloud engineer, a cloud architect, an AI engineer, is this ability to choose the model that's right for your business. Okay, so just going back one step, just trying to respond to another question. So Bedrock basically is this managed service that gives you access to those models. It gives you access to create your own retrieval augmented generation solution as well. So you can use your own corporate data and use it with a large language model to produce and deliver contextual outputs. So for example, like I said earlier, you could use Bedrock to build a chatbot, okay, to interact with your customers. You can also use it to build intelligent chatbots that use existing corporate data. So for example, if you're building a support system, if you are an e-commerce website, you want the LLM to talk in natural language with the end user, but you want to be able to supply contextual and relatable information to the user. So the user says, what's happened to my order number 1478, right? The Bedrock service will allow you to interact with the LLM in order to get a natural response back, but also use your corporate data, which is stored in Bedrock and its related services, so that it sends information back related to that specific order. So that's an example of where you would use Bedrock, for instance. And in addition to that, with guardrails and security measures, you can make sure that the output is acceptable and ethical and morally correct and all of that stuff, right? So for instance, if someone is saying, what happened to my order for something else that's completely unrelated to your organization, then the model can come back and says, there is no such order in our repository. So it knows what you're talking about as well. Okay, so all of those things matter. So like I said, if you're working as a cloud engineer, cloud architect, AI engineer, AI architect, whatever it might be, one of the jobs that you might need to do is compare these models and make a decision as to which model is going to be more suitable for your application. And you need to be aware of the fact that your prompt or whatever it is you're prompting can have different results or different answers. Contextually, it might be the same, but the way how it's delivered to you might be different. Okay, so let me give you an example. What I'm going to do is jump on into the AWS Management Console and let's take a look at Bedrock. Okay, just give me 1 second. I'll reshare the screen. Okay, so here I am on my AWS Management Console, and let me just okay, let me just make sure that it's all visible. Bear with me 1 second. Yeah, okay, great. Okay. Okay, so let's take a look at a particular model. And we'll go into Bedrock. So Bedrock gives you this access to access various models, as I said, and you've got an entire model catalog available for you, right? So you've got different providers. You've got Amazon, Anthropic, DeepSeek, Google. Okay, so if you look at Anthropic, for instance, you've got Claude, Opus, and Sonnet, etc. Amazon obviously have their own. Okay, so you've got Nova Sonic, you've got Nova 2 Lite. So there are different models that you compare, and based on what it is that you're requiring to do, whether you're working with images and videos or whether you're just working with text, you get to choose all of the different models you have. So you can actually use this as well. So if you set up your free plan account, it's a good idea to play around a little bit and see how this all works. But I can take you to something called the playground, for instance, and we can select an Amazon model. So I'm going to select Nova Lite 1, which is input can be text, image, video. The output will be text only. Okay, and I can just apply that. And here I can provide a prompt. So I'll quickly grab a prompt, something like this. Okay, let me just paste this in. So explain how electricity works to a complete beginner using simple language and a water flow analogy. Okay, so this is my prompt. And I'm going to just run that. Okay, so how electricity works explained like water flowing. Okay, so it gives you a good, so it says the water tank is like the voltage because it adds the pressure and pushes it across. So what does it think of a battery, like a flashlight or a power plant as a water tank sitting on a hill? The higher the tank, the more pressure pushes out. So in electricity, this push is called voltage. So okay, so it's using the analogy of a water flow and how water flows and the different elements of it to how it could relate and explain electricity. The pipes, so the pipes through which the water go through is like the wires of how you wire your house. And so wires are like pipes connecting the tank to where you want the water to go. So you need to obviously have all of those electric wires going across the street, okay, to your house, to your building, and then individually getting connected to all the flats in the building, for example, and so on. And so it gives you that prompt. What you can do is you can compare different models. So I'm going to just clear that. Okay. So I'm comparing Nova Lite 2 with maybe Anthropic Sonnet 4.6, for example. Okay. And with some models, with many models actually, you can add more additional parameters in how the model is going to analyze your prompt and provide an output. And I'll come on to these in a minute, but let's just put the simple basic prompt already, and I'm going to run that. And just give me a second, let that run through. Sorry, are you not able to see my screen? Let me reshare my screen. Are you able to see my screen? Can I just get a... Okay. I think someone isn't able to see my screen. Let me quickly reshare. Give me 1 second. I'll stop the share. Oh, it's sorted out. Okay, thank you. Okay, so as you can see, we've got responses back. So you've got Nova Light saying how electricity works. Imagine electricity flowing like water pipe. Let's break it down step by step. Claude Sonnet says how electricity works, the water analogy. Basic idea, electricity is simply the flow of particles called electrons through materials like wire. Okay, so the concepts are still the same. The presentation is a bit different, right? And hopefully you can see how that goes. Okay, so here, if we're trying to compare, let's just compare. Where is the voltage? Okay, so voltage for voltage. Okay, so here water pressure equals voltage. Here voltage equals water pressure. The concepts are still the same, right? but they have just articulated slightly differently. Here you've got an example of a garden hose with high pressure shoots water far, the hose with low pressure dribbles, blah, 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 and so on and so forth. Now, let me just quickly show you something else. What if I added a system prompt? So a system prompt is a set of instructions on how to respond to me. So for example, my system prompt could be something like, and let me just grab a system prompt that I wrote earlier. Okay. You're a primary school teacher specializing in physics and math, and your nature is to explain concepts in detail using real-world analogies. Okay, so I'm going to clear that, and I'm going to put the same prompt again. Okay. So here I'm telling Claude how to think or how to respond. And I'm not doing that with Novalite. I'm going to run that again. Okay, let that run through. And it's just going to hopefully come through any second. Okay. Okay, so Novalite fairly fast. Okay. So imagine electricity like water. So it's doing the same thing, but it doesn't have the system prompt, by the way. Okay. And here, because I said that you're a primary school teacher, we've got some icons as well. Okay, so it's going on just like water flows down just like water flows through a pipe. Electricity is tiny particles called electrons flowing through a wire. Think of electrons like millions of tiny water droplets rushing through the metal wire. We call this flow current. So the language is, is intended so that it's a bit more understandable. And what you might notice also, it's got these icons as well that is put in there just perhaps because it's for a primary school, so they want to make it look nice and all the rest of it. It does go a little bit further into, so it gives you some tables there as well, one last thought, etc. So there's a slight variation now in the way how Claude is presenting the answer, okay, based on what that system prompt is. And you can use that system prompt to limit the scope or extend the scope or just add certain key approaches to delivering your results. Okay, so these are all important elements when it comes to prompting. Right, let's just go back to the slide and we'll come back to Bedrock in a second. Okay. Sorry, let me just reshare the screen. Give me 1 second. Just give me 1 second. Right, so we spoke about the fact that not all models are the same. Okay, and I think we're just going to step back, right? And then I mentioned the fact that with system prompts, you can actually end up, improving the way how the responses are coming back at you as well. So let's just blast out there. There you go. Okay, right? And if we just take this one step further, so those parameters that I briefly mentioned earlier, so like the system prompt, a way of reducing or improving the way how you want the output to be, or you want it to be in a specific format, or you want to include something or exclude certain things, that's really great. But in addition to that, you can also configure how the parameters are used and consumed in order to generate output. So you can control how the model would sample the next token in generation time without changing the model's weights. You have to understand, obviously, what's happening here is the model is predicting the next output at the end of the day using probability and statistics and math and all that wonderful stuff. But how it does it, how deterministic or how probabilistic it is, how much creativity it has, depends on certain parameters that you can configure. So you can configure something called the temperature. This will scale the probability distribution before sampling. So a low temperature will be more focused and deterministic and more repetitive. Okay, so if you set the temperature down to zero point 0.1 to 0.3. It will sharpen the distribution. It will basically look for more factual data, data that's actually in the model, and then it will give you a structured output. A higher temperature gives the model the ability to be more creative, more exploratory, and potentially also leading to hallucinations. Okay, so that's something that you can adjust. And obviously, depending on what your use case is, you might want it to uh, to 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 be more creative, for example. Okay. Okay. Then we have top K. Now, top K is basically this ability to sample only the K highest probability tokens in the next step. So probability wise, what is the probability of the next word? This can be restricted, if you will, to the highest probability tokens or the highest probability words that can come next. So a small K, like if you said K to 10, that will be more tightly focused. If you have a large K, a broader, more diverse range of tokens, words that it can select for the next word in that sentence, in that output that it's going to give you. So the thing about K is you've got to understand that it's a fixed size regardless of how confident the model is, right? So if we take an example, let's take bakery for an example. Let's say that you want to rank the output based on possible words that are likely. So like cakes in a bakery. So, and you say K is set to 5, then what you're saying is exactly the top 5 cakes in that bakery, okay, based on sales are going to be sent back to you, right? And there's no variation in that. There's also another configuration that you can set up, which is known as top P. This is known as nucleus sampling. And here it's going to pick the smallest set of tokens, which is whose cumulative probability is greater than or equal to that value of P. So P can be set to any value that you want, like 0.5 or 0.9. And so here what we are saying is we want to identify the smallest number of tokens whose cumulative probability adds up to P. So if you set P to 0.9 or 90%, then in the case of the bakery analogy, if the sales are spread across a wide range of cakes, for instance, let's say chocolate cake is only 18%, vanilla 12%, lemon 2%, then it's going to have to use a lot more words, a lot more tokens to get that 90% in order to sample from them to give you the outcome. So the higher the p-value and the more spread it, the more unsure the model is, it gives the model the opportunity to select more words, more tokens along the way in order to come out with the output that it gives you. So these are all important parameters that ultimately will allow you to define how those output comes and how those output is derived at and provided to you. And then you obviously need to make a decision as to what the use case is, how creative, how exploratory the results or the responses need to be versus how deterministic, how factual the responses need to be. Okay. Let me just quickly take a look at some questions. So in Bedrock Cohort, it says 0.0 for all TM and columns. Just to confirm, by default, we don't have Cohort to use in Playground. Dave, I can probably take this offline with regards to your question. Feel free to reach out to me on LinkedIn if it's a problem with your account. Yeah. Okay, and Bedrock Cohort says TMP. Okay, sorry, just give me a second. Yes, Vinayak. So basically, like for instance, in Bedrock, you can actually, so let's go back. So actually, let's just give me 1 second. Let me just reshare the screen and bring up my slide. Sorry, bring up my AWS Management Console. Okay. Okay, so for instance, if you're looking at, okay, let me just, yeah, hopefully you should see my AWS Management Console now. And essentially what we're doing here, sorry, 1 second, share the screen again. Here we go. Okay, can you see my AWS Management Console now? You should be able to see it now. Yeah, okay. So for instance, if we go here to Cloud Sonnet, what you can do is you can set the various parameters. Okay. So sorry, Dave says no. No, you should. Okay, Dave, you should be able to see it now. Give me 1 second. Um, okay, can you now see my AWS Management Console? Yeah, okay, fantastic. Okay, so here we can see that if we are using Claude, for instance, we can obviously do a system prompt, but also you can define things like the output tokens. You can have specific sequence tokens that will stop it producing more output. You can set the temperature. So here we can set the temperature. Okay, on how exploratory, how creative you want it to be. You can set top K. If you're setting top P, then it's usually temperature, it's usually top P that you can set the value of there as well. Okay, so those allow you to define how you want it to be, how you want your outputs to be. And then you can also define guardrails. Guardrails allow you to, restrict the kind of output that you want so that it is ethical, it is correct. It doesn't include anything that you don't want to be included in the outputs that are being derived at. Okay, so those are all settings that you can set at the model level when you're using those models. And obviously here we're doing it in the management console, but when you're working programmatically, when you're building your application stack for it, that all can be delivered via your script, via your code as well. So that's not a problem there too. Okay. So hopefully that answered your question about how we can set up the config parameters, Vinayak. Yeah, okay, awesome. I'll just mark that question as done. Okay. Okay, let's go back to the slide deck then. Give me 1 second. I'll reshare the screen for the slide deck. Okay, so using those inference configuration parameters, you are able to, essentially define or determine exactly the kind of outputs that you're looking for. And there are some other variations as well. So other things that you can do is like define max tokens, so the output length cap, stop sequences. These are strings that will halt the generation, frequency penalty to discourage repetition, etc. So there's a vast array of different configuration parameters you can define as well. Okay. Okay, so next, I want to introduce you to RAG, Retrieval Augmented Generation. And this is a whole different topic, and obviously it's quite in-depth as well, but we're just going to do a quick high-level introduction. So with RAG, it basically combines your semantic search with the LLM to generate accurate answers using external knowledge. So as you know, and pretty sure everyone knows this, that the LLMs that you're using, the models that you're using have a timestamp on it, okay, where they don't provide any additional data beyond that timestamp, okay? So there's a date by which after which they don't have any information because they're trained on past knowledge. That said, a lot of models today are also capable of searching the internet. So even though they may not have the data in their database, they're still able to search the internet and provide you with, up-to-date information. Okay, so that's something that's evolved over the years as well. When they first started coming out, there was a hard limit and they couldn't do much more than that, but now they can do searches and stuff, so it gets a lot more flexible. But what they do miss out on is third-party data that is perhaps only available in your corporate organization. And that's something you're going to use or need to use if you're building apps that are going to use generative AI technology. So in the example that I gave, where you have a support platform or a support bot, a support system for your e-commerce website, as a person comes in and says, hey, what's happened to my order number 1, 2, 3, 4, 5, 6? Okay. It's going to generate a response using an LLM so that it is natural language speaking. But obviously, it needs to correlate that order number with a database in your organization to retrieve the order status for that, and then include that and augment that in the response that it gives. So that's where RAG comes into play, and it's an extremely powerful feature. So the idea is to build up this RAG database. You need to obviously collect all of your documentation, gather your data from various sources. This may be live databases that contain current transaction information. Okay, so PDF documents on the internet, documents for your organization, SOPs, for instance, that your organization uses. Okay, and then you need to chunk that document. So you split that document into smaller pieces. So you've got your different chunks that are basically then going to go and get ingested, and you create your embeddings. So you convert each chunk into a vector. Remember those list of numbers using an embedding model of your choice. And essentially what then happens is that gets stored in something called a vector database. Okay. When it comes to actually querying the data, so when that customer types into the chatbot, what happened to my order number 1, 2, 3, 4, 5, 6? The user will ask the question. So in this example, what AWS service lets me code without managing service? It's going to go and query the embeddings database. It's going to go and query the embeddings in the vector database, and it will embed the question using the same model. Okay. And essentially, that question will get then passed, and a similarity search will get performed. So it will search the vector database to find the most similar relevant vectors. And ultimately, it will retrieve and return the most relevant document chunks using those chunks. So in this case, it's picked up AWS Lambda allows you to run code without provisioning service. It automatically scales your code in response to incoming request. And it will use that piece of data to augment with its response. So it will combine the question and context into the final LLM prompt and then generate an answer with that. Okay, so it'll come back with the answer. AWS Lambda lets you run code without managing service. It automatically scales and runs your code in response to requests. Okay, so that's pretty much how RAG works. And I'll do a quick, simple demonstration to kind of illustrate this as well. So give me a second. Let me just reshare. Okay, so you should be able to see my screen again. Okay, so I'm back on to my AWS Management Console. And what I'm going to do is I'm going to create a simple RAG example here. Okay, so when you create RAG or you create what are called knowledge bases on Bedrock, so this is really, really powerful. So we can go ahead and go down to build and create a knowledge base. Now, obviously, I need raw data. So before I do that, in fact, what I'll do is I'll create an S3 bucket and upload some data. Okay, so let's go back into S3. And hopefully you're beginning to see that we're using S3 almost everywhere and anywhere. Okay, and it seems to form the basis of a lot of your storage component for any application that you use. And I wanted to highlight this fact that there are some of these core services that you'll always be using for any application stack that you build out. Okay, so on the left, I'm going to go ahead and go to general purpose, create a bucket, make sure it's in the United States, and I'm going to call this one belly brew. So have you ever, you probably had, have you tried kombucha? Anyone tried kombucha? Do you know what kombucha is? Yep. Awesome. It's a health drink. It's made from fermented black tea, and it comes in different flavors, and it's really great for the gut. Okay, so belly brew, I'm going to call this belly brew kombucha docs, something like that. Let me see if I get that name. go ahead and create a, no, it already exists. Let's call this one KB docs. Okay, so knowledge base documents. I'm gonna create a file there. Okay. Okay, so I've got a bucket called Belly Brew Kombucha KB Docs. Belly Brew is the name of the company. It's a drinks manufacturer, and yeah, basically they manufacture kombucha. Okay, so now what I need to do is I'm going to supply it with some documents. So these are some raw materials or some raw documents. So I've got documents here that talk about raw material sourcing, fermentation process, sanitation, hygiene, and so on and so forth, right? And I'm going to add all of these. So these are my knowledge-based documents. These are proprietary to Belly Brew Co. Limited. I'm going to dump it in there and upload it. Okay. Right. So I've got my raw data. And I'm going to go back to my knowledge base and I'm going to go back to Bedrock and create a knowledge base. So we're going to create a knowledge base with a vector store. And I'm going to give it a name. So Belly Brew Kombucha KB. Yeah, that's, I'll give it a slightly different name. SOP, let's call it SOP. Okay, for my standard operating procedures. It's going to create a service role. Again, I'm going to highlight the fact that IAM roles are really, really important because they allow one service to talk to another service. Remember, we spoke about this yesterday, and this is how you build solutions with security in mind at the end of the day. So it's going to create a service role for you. You can create your own and then specify exact permissions. We're going to let it do the job itself. And our data source is that S3 bucket, that S3 bucket that contains all of our raw SOP documents. Okay. And I'm just going to go ahead and click next. Okay. And so the data source is Belly Brew KB docs. Yeah, that sounds fine. Fine. It's just the SOP docs, right? SOP docs. And the actual bucket that contains the data is this one, Belly Brew Kombucha KB docs. Okay. Now, when it comes to parsing that data, there are different options available. You've got the default parser, which is absolutely wonderful for text. So because our documentation is all in text anyway, we might as well use that. But if you're using PDF, images, video, and audio, then you've got different parsers as well that you can use as well for that. Okay. And you get to choose the type of chunking strategy. So we'll just use the default one for now. Click next. And this is where you're going to select the embeddings model. Okay, the embeddings model allows you to define exactly what, there are different options you have. So I'm going to select this one, which is Titan Embeddings G1. You can have some additional configurations as well. And we need to store this in a vector store, right? And there are different options available to you. There's OpenSearch, there is Aurora PostgreSQL Serverless, and then there's Neptune Analytics, which is GraphRag. From a cost perspective, you'll find that the Amazon S3 Vectors, which is fairly new addition to the service, is the best one to go for. The others are quite expensive, but in a production environment with very large demand, you might need to consider something like OpenSearch, for instance. So we'll go for vector S3 vectors for now, and I'll click next, and I'll basically create the knowledge base. At this point in time, what it's doing is it's actually going in, looking at my raw data. So it should have started. Yep, it's looking at my raw data. It's creating those chunks. It's going to do all of those embeddings, and everything is going to run in the background for me in order to build up that knowledge base. So we'll give it a couple of, it usually takes a minute because I don't have much data, obviously. And okay, yeah. So it's created successfully. Now we need to sync the data source itself. So we've got the actual, we've got that actual S3 bucket there. Okay, so I'm just going to sync it up. Okay, just wait for that to happen. Okay. Okay, so Vinayak, you have a question whilst this is happening. Is there a way to ensure that Gen AI does not have hallucination, does not fake data? So here again, you're going to use retrieval augmented generation as a great tooling for you to ensure that it doesn't generate fake data. So for instance, you can actually create your system prompt that says you're only allowed to respond with the data that's in my RAG. Okay, so that's one way of ensuring that you limit any kind of hallucinations from happening. So it needs to extract factual information before it responds to you from your database, from your RAG, collection, and then it's able to then generate that response using an LLM so that it's more natural way of communicating with you. Okay, so that's one way of doing it, where you can reduce and not have hallucinations. Okay. All right. So yeah, let's just give it another minute. That should complete fairly soon. Refresh the page as well. Yeah, so knowledge base is basically your ability to create a RAG, and there are different types, obviously, and there's a lot more to it. Obviously, we're not going to cover all of it right now, but yes. Okay, so that's synced up our data source. So we can actually test our knowledge base. Okay, so I can go ahead and select a model. So here I can choose to retrieve data only from the data source or retrieve and use response generation. So query the data source and generate a response based on the retrieve results by using a specified foundation model. So I can use something like Claude Sonnet 4.6, and I can prompt it in that, using the data held in RAG. Okay. So for instance, I might have a question like this. Can you just paste a question in there? Okay. What's the ideal temperature at which fermentation should occur for kombucha? Okay, so I can run that. Okay, so it says the ideal temperature range for kombucha fermentation is between 24 to 29 degrees Celsius, roughly 75 to 85 degrees Fahrenheit. And it's actually picked that up from my document, and it gives you a citation there of which document it picked that up from. Okay, so it's the fermentation process.txt. And if we look at that document in detail, you'll see that in fact, so let me see if I can bring that up. Fermentation process. Okay. And okay, so give me a second. So this is the raw document. Okay, and you can see here, sorry, let's just search for that again. Yeah. So it should be between 24 and 29 degrees Celsius, roughly 75 to 85 degrees Fahrenheit. So here we've avoided the model from going out onto the internet and looking some examples on the internet and bringing back that data. Is actually first checking my document, because maybe my fermentation process might be slightly different. Maybe the temperature might be varying compared to what's generally recommended out there, okay, based on how I'm producing my beverage, okay, and going through my manufacturing process. So this is where RAG and knowledge bases become really, really powerful. And it allows you to avoid all of that hallucination and creativity element as well when you're working with with generative AI. Okay, so that was a quick example of how you can use RAG and knowledge bases on Bedrock. Okay, let's move further on. And we'll go back to just reshare this. Okay, so that was RAG. Okay. And that was a quick RAG demo that we did over there. Okay. All right. So next, couple of things that I want to sort of mention whilst we're still on the topic of Bedrock and generative AI, and that is to understand the key difference between deterministic and non-deterministic. So this is one of the most important differences between traditional software and AI-driven workloads. So traditional software is deterministic. You basically have an input and you know what that output needs to look like. So 2 + 2 always has to be 4. This approach to software engineering means that unit tests can pass reliably, behavior is predictable and auditable, it's safe for regulated and high-stakes systems, and debugging is pretty straightforward. AI workloads, on the other hand, are non-deterministic because we're talking about statistics, probability, math, etc., in order to generate output. So there is chances for hallucination. So it could be confident but give you the wrong answer. And using RAG technologies and knowledge bases help you reduce that. Inconsistencies, because it will give you a varying response each time. There could be bias based on the patterns of the training data. It used to be the case if you were using ChatGPT 2 years ago, and if you typed in, give me an image of a clock that says 2:45, it never worked. It will always give you, I think it was 10 to 2 or something like that, because that was the only training data it had. But that's changed over the years. So the more training data you add to it, you reduce the possibility for bias. Okay. So this is really important because if you are working for an organization that's building its own model, then you have a situation where you really need to have vast amounts of data so that you avoid that bias element to it. Temperature is another way to actually control randomness. Is there a way to detect bias and hallucination? Yeah, you need to actually obviously compare it with the data that you have to be able to then identify whether there is hallucinations taking place. You need to perform that check, that audit, and go back to your original data and see whether or not there's some bias taking place. There's no really other way of doing it. So you need to incorporate testing as part of your process when you're building your application stack. Okay, guardrails, I briefly mentioned that earlier, so we'll quickly talk about that. So different types of guardrails are obviously available. You've got content filters. You can deny topics. You can use word filters that allow you to specify actual words that you do not want it to respond to. Sensitive information. So here it can detect things like personal health information, PII information, and contextual grounding checks. So reduce hallucinations and RAG is another thing to use. Okay, so you've got different filter types that you can configure. You would set up a guardrail or multiple guardrails and then attach that to your knowledge base before you release it out into production. Okay. All right, we're going to go ahead next and just talk about 3 other different AWS services that relate to AI and machine learning. The first one is Amazon Recognition. So Amazon Recognition is basically a deep learning model that is able to analyze and understand video and perform image and video analysis. So it allows developers to add computer vision features to the application without requiring any machine learning expertise. It leverages deep learning technologies, offers easy to use APIs that can analyze images and videos stored in Amazon S3. And so, for instance, it can understand computer vision, it uses deep learning and image classification, and you can build various applications with Amazon Recognition. So I'll give you a simple workflow example. So speed cameras, okay? CCTV and speed cameras are everywhere nowadays. So if you're speeding, which hopefully you're not, then there's a good chance that a camera is going to capture your license plate information. That's going to be fed into something like Amazon Kinesis, which captures video streams So this is another product as part of the analytics offering from AWS. So you don't need to build your own streaming solution. You can use Amazon Kinesis to help you build that application. Amazon Kinesis can then send that data, that raw data, it can sit in Amazon S3. That can then trigger a Lambda function. So as the images are captured of the license plate of that car that was speeding, it can be captured in Kinesis. It can be stored as an image in Amazon S3. We spoke yesterday about how anything that you create in Amazon S3 is an event. Okay, so it's an object create event. That event itself can send out a notification to a Lambda function. The Lambda function can use Amazon recognition to capture the text of that license plate. That license plate can then be compared with the DynamoDB database, so a huge database of who owns this license plate or which car has this license plate. And it can then go to an app that basically monitors or has details of all of the vehicle registrations out there and then automatically send out a ticket to you via email. Okay, so in your email or in your SMS, you've got a ticket to say that you've been speeding on so-and-so date at so-and-so time and we caught you speeding. Okay, there's a fine example of where you might use Amazon recognition, for example. Okay, another service, another AI, ML, deep learning service is Amazon Poly. This allows you to convert text to speech. Okay, so here you can basically convert text to lifelike speech. So it improves accessibility and user engagement, supports multiple languages and natural voices. Some key features include the ability to use plain text or even speech synthesis markup language for advanced control of things like pronunciation, pitch, speed, and volume. You can access multiple male, female options by language. It includes bilingual voices. The output can be in MP3, PCM formats, mobile, IoT, and even telephony applications as well. And Poly allows you to basically convert that speech into natural language as well. Okay, so it's fairly easy to use. And again, you can incorporate that into your application stack rather than building out, which would be quite expensive and prohibitive for many organizations. You can use Amazon Poly, which is a fully managed text-to-speech service that you might want to use. Another tool is Textract. So this allows you to extract data from a wide range of sources. So textual data, that is. So for instance, you can use AI services for extracting text from data from scanned documents. It can detect both typed and handwritten text. It goes beyond normal OCR, optical character recognition, by understanding document structure. And some key features include identifying printed and handwritten text in various documents. It can extract structured data using document analysis API. So it can see tables, it can see labels. It can perform queries. You can pull specific information with pre-built or custom queries. So something like expense processing, you can extract data from invoices and receipts. So it can using the analyze expense API as well. It can perform ID processing, so it can use things like US driver's license and passports using the Analyze ID API. Lending workflow, it can automate things like mortgage loan application processing using the Analyze Lending API and so on. So it's an absolute brilliant piece of software, or AI service, I should say. And you can use it uses machine learning to understand document layouts, not just scan text, but it also is able to extract contextual relevant information like fields in the forms, entries in tables, etc., accurately, making data more usable to downstream applications. If we take a look at exactly how you would use Textract, there's two methods. There's what's known as synchronous versus asynchronous Textract processing. So synchronous is where basically you have a really small document, maybe a one page, and you send it to Textract, and Textract is able to extract the data and give you the output from it, okay, in any format that you want. So this could be single page forms. It could read a receipt and tell you what the total is, etc. ID doc, okay, to extract information from your passport or from your driver's license, etc. Another way you would use Textract is asynchronous. because you might be trying to extract data from multiple documents or a very large book with 50,000 words in it, that's going to extract some time to do so. And so what you don't want to do is waiting and ending up with a timeout scenario where your upstream application is not able to continue the workflow. Okay, so here you might supply it with multiple documents, PDFs, books, etc. You hand over the job to Textract. Textract will perform the actual extraction and then may send a notification to a downstream resource. Okay, so yesterday we spoke about SNS, and you were able to see how we would use SNS to trigger the completion of one task to something else, like either send out an email to say, hey, your order has been completed, or to a Lambda function to say, someone has uploaded a file to an S3 bucket, do something with it. Like, for instance, convert it to an HTML document so we can create our resume website with it. So those sort of things would require you to configure and use Textract as an asynchronous tool. And what I'm trying to highlight over here is the use of different services and resources to build that complete workflow. Okay, so you're looking at all of these different services: Bedrock, Textract, Poly, S3, Amazon SNS, SQS, CloudFront, and hopefully you're beginning to see just how intricate it is when you are trying to build a solution, because you need to use these various services, each service performing a specific task along the application workflow. Okay, and slowly you're hopefully in a position to then see that, okay, if I need to deploy my application in the cloud, I can either build everything from scratch and host it onto a server and then manage all of the infrastructure myself, or I can use all these different services to ease my application development lifecycle. So that's where we are with all of these different services, and why AWS offers more than 200 different services at the end of the day for you to build your end-to-end application solutions. Okay, and pretty much that's where we have come to the end of in this session today. I hope you're getting excited, and if you've been with us over the last 4 days now, you're beginning to see just how exciting and how rewarding it is in order to work out these different technologies and use these different technologies together to build a solution. And if you're actually looking to go further on, then obviously, build real projects, become job ready, and get AWS certified. I'll talk about my AWS Accelerator program tomorrow once we've completed the project as well, so you can take a look at that if you're interested. But for today, what I want to do is actually leave you with a small homework. Okay, so we're pretty much coming to the end of today's session. This session is obviously being recorded. It's available on our YouTube live broadcast, so that recording is going to be available to you. Watch the replay. Think about how you would build that resume generator website that I was talking about right since from day one, okay? And using AI services, all of the different tools and technologies to build that workflow. We spoke about things like S3, IAM for permissions and authorizations. We spoke about CloudFront. We've spoken about Bedrock. We've spoken about EC2. We've spoken about ECS Lambda. Today, we've looked at Textract, Poly, Recognition, and Bedrock as well. It'll be really great if you can just spend a little bit of time this evening and just think about which of those tools and technologies you want to use in order to build this application that allows the user to upload their resume, and the application generates a website and publishes it out on the internet. And if tomorrow you can just give me a quick synopsis of what you think the solution should look like before we actually get started with the demo, that'd be really awesome. Okay. All right. So that's pretty much the end for today. Any questions? Any doubts? Anything you want me to talk about very quickly before we end today's session? Thanks, Vinayak. Appreciate it. Any questions at all? Okay, if there are no questions, just putting on the screen up there. So obviously, if you want to watch the video and you haven't made a note of our channel already, there's the QR for the channel. Okay, so please do watch this recap if you need to refer to anything. And thanks, Manzania. So yeah, please do watch that recap, okay, and have a think about how you would build this website, this resume website generator application. Okay, it'll be really awesome if you just give it some thought. Which of those tools that we've discussed this week you're going to use in order to build a solution for you? Okay. And again, if you haven't already connected with me on LinkedIn, then please do. And our website provides access to various courses that you can also look into. Okay, so if there are no more questions, then we're going to end for today's session. Thank you so much for taking the time out. I really appreciate it. You have a nice evening. Thank you.